This module covers some of the conceptual design details that apply to single-lane roundabouts. After developing the basic footprint, evaluating the size, shape, and placement, and coming up with the preferred position of the roundabout, we then move into laying out some of the curb lines, splitter islands, crosswalks, sidewalks, and other details to be able to take it to a fully fleshed out concept ready for evaluation. Guidance on curb types for the various elements of the roundabout are provided in Figure 3-36 of the GDOT Roundabout Guide. This includes curb and gutter around all perimeter outside curb lines in all corners, 2-foot gutter pan, and a Type 2 curb face. Around the central island, the outer perimeter adjacent to the circulatory roadway utilizes a 4-inch tall concrete curb and gutter or an integral median with a Type 9 curb face that provides a mountable curb profile that allows for easy navigation by tractor trailers as they trek around the central island and the trailers need to mount up over the truck apron. At the back of the truck apron, we utilize a curb and gutter or integral median with a Type 1 curb face. Along all of the splitter islands, a 6-inch Type 7 curb face is used with a sloped curb face. This provides a little bit of a sloped back curb profile to avoid any tire scrubbing with trucks as it goes through, and that utilizes the same 2-foot gutter pan or an equivalent 2-foot offset if a gutter is not utilized. In corners or along the entries where an outside truck apron is used, you would maintain the same Type 2 curb face with curb and gutter leading up to the start of the truck apron. And at that point, you would transition into a Type 9 mountable curb face along the perimeter of the truck apron with the Type 1 curb face along the back of that mountable outside apron. The length of the splitter islands will tend to vary based upon site context, and there's a number of considerations that we need to think about. One of those is the speed of the approaching vehicles approaching the intersection, but we also need to consider the length of the splitter island needed to provide channelization through any horizontal curvatures upstream of the entry, make sure that we're utilizing that splitter island length to achieve the speed control that we need for fastest paths through the roundabout, taking into account any access considerations for properties in the near vicinity of the roundabout, etc. As a starting point, the GDOT Roundabout Design Guide provides some general guidance that for higher speed facilities, we would generally want longer island lengths to provide additional visibility and additional channelization. For speeds greater than 45 miles per hour, typically the island length of 200 feet is a good starting point. Getting into the 35 to 45 mile per hour range, 100-foot long splitter island is a good starting point. So a little bit shorter. You can go longer if you need it for channelization. There's flexibility to go slightly shorter if you need to for access considerations, but 100 feet's a good target. And then in that lowest speed range, less than 35 miles per hour, we have the most flexibility. And so going down to as low as 50 feet is allowed. 50 feet should be considered the minimum. That's the length that's necessary to provide some good visibility, enough size to the island that it's visible to an approaching driver, and then also have enough length that you can get a raised pedestrian refuge with enough of a nose on it to provide adequate protection to those pedestrians. The other thing that we want to consider is the geometry of the approach nose itself. As illustrated in Figure 3-9A of the GDOT Roundabout Design Guide, we want to offset the face of the curb 2 to 4 feet away from the lane line to help with funneling those drivers in as they're approaching the intersection and having the curbing being added to the typical section. The nose of the island itself is typically a 1.5 to 3 foot radius to allow for a large enough nose to make it visible to drivers. NCHRP Report 672 provides additional details related to the splitter island design. This includes the pedestrian refuge area, where a minimum of 6 feet in width is needed. This is required in order to meet ADA for providing 2 feet in width of detectable warning surfaces on each side of the pedestrian refuge, as well as a minimum of 2 feet of clear space in between those detectable warning surfaces. The 6-foot width also helps to support pedestrians pushing strollers or a cyclist that is walking their bicycle across the pedestrian crossing to be able to fit within that refuge area. At the end of the splitter island, we want to make sure that we are utilizing some offsetting and blunting of the approach nose near the circulatory roadway as well. We would apply a 3-foot offset to the lane line, as well as a 3-foot radius to the approach nose. The other nose adjacent to the entry, we can use a smaller radius, typically in the range of 1 to 2 feet. Moving on to pedestrian facilities, there's a number of different considerations and elements to the pedestrian facility design. We're not going to cover all of that in this short presentation, so I encourage you to refer to NCHRP Report 672, NCHRP Report 834, as well as the GDOT Pedestrian and Streetscape Guide. Some of the general topics that we want to cover are the pedestrian crossing distance and locations. For a single lane roundabout, we're typically going to set back 1 car length from the roundabout. This illustration here details out a multi-lane design, but for a single lane entry, we want a 1 car length setback, which is 20 to 25 feet between the front of the crosswalk and the yield line, which allows for 1 car to be stored in between the crosswalk and the entry. The same general dimension is used on the exit. In some cases, the exit distance can get pushed back just a little bit further so that you can get a nice angle point in the center of the island. When setting the distance of the crosswalk, it's usually more important to try to get this entry distance pretty close to that 20 to 25 foot range so that you don't have multiple vehicles sort of stopping on top of the crosswalk. The crossing alignment has a couple of options as well. A common starting point is to use an angle point as illustrated in the figure, which would be perpendicular to the outside curb line on both the entry and the exit, and then providing an angle point within the splitter island as that pedestrian changes direction. When utilizing this strategy, you typically want to make sure there's enough width to the splitter island that a visually impaired pedestrian might be able to detect that change in direction from the curb lines. If you have too narrow of a splitter island, they may pass straight through on their original alignment without realizing they needed to change direction. So for narrower splitter islands, looking at an alignment that just crosses straight across the roadway, perpendicular to the center line, perpendicular to the splitter island, is another alternative. The key there is just making sure that the ramps along the outside curb lines are adequately aligned with the crossing itself. We discussed on the previous slide some of the considerations related to splitter island and pedestrian refuge design, making sure that we have at least a minimum of 6 feet in order to provide for ADA. We also want to think through some of the visually impaired pedestrian elements. This topic gets into a lot more detail in terms of some of the navigation needs of visually impaired pedestrians around the roundabouts. And generally, we want to make sure that the visually impaired pedestrians are able to locate the crossing, that the ramps and the detectable warning surfaces help to align those pedestrians with the crossing, that they have the cues to get across. And along the outside curb lines, that we want to make sure that the sidewalks are physically separated from the curb lines to help to channelize those pedestrians to the crossing locations. So we typically have a minimum of 2 feet of sod or landscape buffer or contrasting surfaces separating the curb from the sidewalk. In general, we want to make sure that the placement of the pedestrian facilities is also discouraging pedestrians from going to the central island. In some situations, outside truck aprons are required in order to accommodate the design vehicle or other oversized, overweight control vehicles through the roundabout. Whenever we're applying outside truck aprons, we typically want to try to start by avoiding having them cut through the pedestrian crossing. This creates additional conflict points and additional complications for grading of that mountable truck apron, as well as trying to meet all of the ADA requirements for the ped ramps and the cross slopes within the crossing itself. In some cases, it's possible to shift the pedestrian crossing location an additional car length back, so you'd have a 2-car length setback in order to get just out beyond the position of the outside apron. In other situations, that's not going to be possible. The length of the outside apron is going to be long enough that you'd be shifting the pedestrian crossing too far back up the leg and would be getting into a higher speed environment, which would be undesirable for the pedestrian crossing. So in those situations, GDOT has developed a detail that would allow for the pedestrian crossing to cut through the truck apron as sort of a last resort. When applying this type of treatment, you're utilizing your typical ADA ramp at the back side of the truck apron, and then you're cutting the crossing at grade with ramps on either side of the truck apron. So as a truck trailer is navigating across the apron, they're in an elevated position here, and then you have a ramp sloping down to the travel lane grade and then back up again on the other side. We want a max of an 8% grade on our ramp and making sure that we're providing the striping through for the pedestrian crossing that goes through the depressed apron so that we're clearly delineating the pedestrian space there. The detectable warning surfaces would go on the ADA ramp at the back side of the truck apron to define the edge of the pedestrian space at this point. Figure 4-3 and 4-4 of the GDOT Roundabout Design Guide provides GDOT specific preferences for design details for bicycle facilities at roundabouts. This includes things like the taper location and taper rates for where you're dropping bike lanes, design of any ramps for bicyclists up onto a shared use path, and other considerations. In general, any wide shoulder or bike lane that's present upstream of the roundabout would be terminated prior to the entry. Cyclists using the shoulder or bike lane would then have the option of either merging into the travel lane and traveling through the roundabout as a vehicle, or exiting up onto the shared use path and navigating around the roundabout on the path facility. The placement of this taper transition needs to be at least 50 feet upstream of the crosswalk to make sure that we're separating any conflicts with pedestrians at the crossing location itself. But we want to make sure that it's no more than 100 feet upstream of the yield line. And that is to make sure that we're keeping any of these merging maneuvers with bicyclists into the travel lane at that lowest speed environment where vehicles are slowing down prior to entry. For some of the taper design, we want to use an 8-to-1 taper and then use a 45-degree angle for the 5-foot wide ramp if we're transitioning bicyclists up onto the shared use path. Ramps on the entry and on the exit are fairly common, if not a standard feature for multi-lane roundabouts, given the additional complexity of those facilities. For single-lane roundabouts, they tend to be more optional. For single-lane roundabouts, you have a simpler configuration and generally have slower speeds. And so the use of a ramp becomes an optional facility. In some cases, there's a desire just to maintain a standard width 5 or 6 foot sidewalk around the roadway and keep the cyclists on the roadway facility. But in areas where you have higher cyclist use, where there's additional multi-use paths already present that you're trying to tie into, the provision of ramps at single-lane roundabouts are certainly an option as well. Additional design details related to the placement of these features is provided in the figures, and I encourage you to refer back to the GDOT Roundabout Design Guide for additional discussion. In this exercise, we will further add horizontal design details, including the splitter island, curb and gutter, pedestrian crossing, sidewalks, bike features, and assess the truck apron width needs based upon the design vehicle swept paths. We're going to start by laying out the splitter island for this west leg as one example. The splitter island supports vehicle channelization and speed control through the entry and exit. Section 3.10 of the GDOT Roundabout Design Guide identifies that the splitter island length is going to vary based on the speed context. And for this example, we have a 50-mile-an-hour posted speed along this east-west roadway. For speeds above 45 miles per hour, the GDOT Roundabout Design Guide suggests a desired splitter island length of about 200 feet. However, slightly longer or shorter could be possible depending upon practical design considerations. Considerations such as driveway placement, approach visibility, and channelization all kind of factor into that final splitter island length that ends up getting used. But for starting purposes, we're going to use that desired 200-foot splitter island length and lay that in as a point of reference. Note that for this overall longer splitter island envelope, we would end up with about half of that envelope would be a raised island and the rest on the approach would be striped out. In this particular case, it may be beneficial to actually extend this island a little bit further away, make it a little bit longer than 200 feet in order to get that curb line along the splitter island through this initial curve, um, so that we're able to support a little better channelization and speed control coming into the approach. This is really going to be one of those controlling radii along this edge of the splitter island. The other benefit is if we get the nose of that island around the corner a little bit further, we're a little more along the tangent here. So approaching driver has a little better visibility of a nose of the island right in this area than they would if it was a little further up around the corner and a little further out of their cone of visibility. So for this particular case, we're going to look at just extending it a little bit longer than this 200-foot offset line. I'm going to delete it. GDOT recommends the use of a Type 7 curb with a 2-foot gutter pan or a 2-foot offset if using a monolithic island. And so the next step we're going to do is go through and lay out our raised curb within this splitter island envelope. So we've got 2-foot offset. We're going to start and make sure we're carrying that curb down through that initial horizontal curve as we just discussed. And then we're going to work our way through these additional geometric elements. The next thing we want to look at is the nose of our approach and then the noses along the edge of the Circuit Square roadway. We'll start with the approach nose. GDOT recommends a 2 to 4 foot offset for this island nose with a radius in the range of 1.5 to 3 feet. And really the goal of trying to have a little extra offset on this approach nose is to help funnel and channelize vehicles so there's no abrupt edge of this island right along the edge of the roadway that the drivers are encountering. So within that typical range of 2 to 4 feet, we're going to split the difference and use a 3-foot offset for this particular location. And I'm just going to set an offset line there as a point of reference. And then we're going to use a 2-foot radius for this approach nose. Again, splitting the range, typical range of 1.5 to 3 feet. We're going to use a 2-foot nose here. And then what we'll end up doing is deleting this construction line and then inserting a transition in between our nose and our typical 2-foot offset. In some cases, you can use just a standard tangent transition in between these, but just due to the proximity of this initial horizontal curve, we're going to end up needing to use an arc transition on this one. I typically use something in the 150 to 200 foot range, but there's some flexibility for this dimension. I'm using 200 foot for the purposes of this demonstration, just to give you an illustration. And really, as you can see, what that ends up doing for us is as a driver is approaching the intersection along this tangent, we got that nose around the corner where it's visible kind of on that tangent before the driver's getting into this horizontal curve. And then it's just providing that little bit of funneling so that the driver doesn't have that abrupt edge that they're encountering and kind of funnels into this section where you're going to end up having curbing on both sides of the vehicle. The remaining splitter island noses are going to follow a similar approach. For the exit portion of the splitter island nose, we're going to use a 3-foot offset again, and we'll create some construction lines here along the ends. And then we're also going to use a 3-foot radius just to have a little larger nose on this exit side. We'll delete those construction lines. And then we're going to just implement a tangent transition in between our nose and our 2-foot typical offset on both sides here. Note that for wider splitter islands, you're going to end up with a little longer section between, along the edge of the circulatory roadway that's going to be curved. Um, and so you'll end up with your tangent transition and then a longer section of curved length. In this particular case, we end up with a really short section of curved length just because of this being a little narrower overall splitter island. So by the time that I trim this up, I'm only left with a couple of feet here of this curved portion of the end of splitter island. So for this particular example, I'm actually going to remove that piece so that we end up with fewer inflection points along that curb line. We're just going to put our nose directly between this tangent and the 2-foot offset on the approach side. I'm going to use a little smaller 1-foot radius on this nose. And the goal here of using the smaller radius is to really emphasize the channelization, get this nose as far around the corner as possible so that vehicles are being channelized in the correct direction of the circulatory roadway. So once we have those elements, we can finish trimming that up and we have our splitter island established. From there, we can proceed on into developing our outside curb lines. Type 2 curb and gutter is typically used along the outside curb line, which has a 2-foot gutter pan. So we'll go through and lay in a 2-foot offset from our edge of pavement through our entry and exit curves to establish that 2-foot offset. Now, note that the length of the curb line along the outside does not need to necessarily match the length of the splitter island. In some cases, your outside curb line may end up being longer than your splitter island, and in this case, we'll likely end up with a splitter island that's quite a bit longer than our outside curb line. Um, the outside curb line is going to be driven by some different practical design considerations, vertical design, drainage needs, as well as what might be needed to support your fastest pass speed control and channelization coming into the roundabout. Some other considerations are whether you're tying into a closed section where you have drainage inlets or whether you're transitioning into open drainage swales along the roadside. Typically, we want to make sure that we're getting our raised curbing along the outside at least 100 feet upstream of the entry. So if I do a 100-foot offset from the edge of the circulatory roadway, we can get a rough idea of where that falls. So a little bit further back than what I've laid out so far. On the exit side, we typically want to get back at least through this exit curve. So we could potentially shorten that up from a practical design perspective if we wanted to transition the drainage a little bit quicker. But really, some of our driveways and drainage and all those types of things are going to ultimately influence the exact length of where we're dropping that outside curb line. The other thing to consider is what we're tying into in terms of our approach typical section. So commonly, you would have at least a 5-foot paved shoulder that would allow for use by cyclists along the outside for this. So for this east-west state route, we would assume that we have a 5-foot shoulder that we're tying into. Carry this up. Between these areas, we're going to have to transition from our 2-foot curb face offset back to our edge of our 5-foot shoulder. Same here, we'll need a transition zone. Typically, what we want to do is provide a taper through these areas to support bicyclists that are using the roadway and transitioning in and out of that paved shoulder. And so what we want to do is try to get that transition zone within about 100 feet of the edge of the circular roadway, but at least 50 feet back from where the crosswalk is going to be. So before we lay in these transitions, we want to go in and next lay out our crosswalk. For our crosswalk, we typically want to have that set back at least one car length from the edge of the circulatory roadway. Commonly, we try to get it exactly one car length, but there is some flexibility if you have things like an outside apron and need to push it back one extra car length. So the dimensions we're going to use are in the range of 20 to 25 feet to establish that car length. And we're going to use a 20-foot offset for the purposes of this demonstration. I'm going to measure that from the edge of this raised splitter island, which gives us just a little bit of buffer to that painted lane line. In addition to the 20 feet of storage, we're going to end up with a 10-foot wide pedestrian crossing. So if I'm working to the middle of that pedestrian crossing, I'm going to have 25 total feet to the edge here, plus another 2 feet for that offset. So that's a total of 27 feet. So I'm going to set a circle as a guide that's got a 27-foot radius. And then what I can do is snap to that, the tangent, and then snap perpendicular to my outside curb line. And that is establishing the center of my pedestrian crossing. So if we have a 10-foot crossing, we'll offset 5 feet on either side of that line. And now we've got our overall ped crossing set up. And if we just do a quick double check, that should put us 20 feet back approximately from the edge of that raised splitter island. So we're within that 20 to 25 feet of the marked entrance line. So that's where we want to be. And what we'll do next is extend the center line up to approximately the middle of the splitter island. We want to try to get an angle point established as close to the center of this splitter island as we can get. The dimension for 20 feet on the entrance is a little more important than on the exit because of the fact that we have a vehicle yielding here and we want to try to accommodate the storage of that one vehicle. If we end up with a little bit longer of a distance on the exit, that's okay. We still want to try to be within that 20 to 25 foot range, but slightly longer is okay. So we're going to utilize the extension of these lines to about the center here, and then we'll snap to the end of that point, and then we'll snap perpendicular to the outside curb line here. So that establishes an alignment that's perpendicular to our curb line at the center of the crosswalk. And then as we offset 5 feet to either side, we end up with our angle points along the curb lines that's approximately in the middle of that splitter island as well. Once we have our pedestrian crossing alignment set, we can come back in and do a quick double check on the size of our pedestrian refuge within the splitter island. We need at least 6 feet of width at the narrowest point to make sure that we've got enough room to accommodate somebody pushing a stroller or walking a bicycle across the crosswalk. In this case, we do. We have at least 6 feet there at the narrowest point, so we're exceeding the minimum. Often having a little bit more room within the refuge is desirable, but at least you want to get that minimum 6 feet. The other reason for the 6-foot dimension is from an ADA perspective, you have a 2-foot wide truncated dome detectable warning surface along each edge of the refuge. And then you need at least 2 feet of width between those truncated domes to detect the gap, detect the area where pedestrian space begins and where the roadway space ends. And so that 6-foot dimension makes sure that we're meeting that at least that 2-foot minimum gap between those truncated dome detectable warning surfaces. For splitter islands that are a little bit narrower in width, one of the potential trade-offs is that if you had a visually impaired pedestrian that is crossing through the center of the crosswalk, there's the potential that they could sort of travel straight through the crossing and miss these angle points, miss the change in alignment. So if that's the case, if you have a particularly narrow crosswalk, an alternative could be to use a alignment that is straight across the overall approach as opposed to perpendicular to the individual entries and exits. So to do that, we would lay out, I'm going to use 22 feet, which is going to be 2 feet back from the edge of the ICD to the start of the splitter island nose, and then our 20-foot setback to the crosswalk. I'm going to set a circle there as a template. We've got about 6 feet of width within this raised portion of the splitter island. So I'm going to offset that 3 feet to identify the center of the splitter island. And then we can pull a tangent from our circle perpendicular to our approach center line and then extend that across and then offset 10 feet to establish the other side of our crossing. So that's another option in red as an alternative crossing alignment. The pedestrian crossing ends up in about the same place from a pedestrian navigation standpoint. It's a straight crossing for somebody that might be visually impaired. But the key here is if you go down this type of strategy, that the ramps at either end of the crossing would not be able to be perpendicular to the curb line. They would need to be in line with the crosswalk itself so that the pedestrian, as they're reaching the crossing, is aligned with the crossing location. But this still sets us back that 20 to 25 feet away from the entry and exit. It's just that the vehicle, as it's kind of following the curb lines, is not necessarily oriented quite in line with the crossing. So there's trade-offs to either approach. For this island, we're probably large enough that we can have a defined enough angle point that going with the angle is sufficient here. But just keep that in mind if you end up with a pretty particularly narrow crossing. Once we have this established, we can go through and break some of these elements and then use these lines to establish our uh, markings. But within this area of the splitter island, we can either leave them as angle points, or if we want to try to soften them up a little bit, we could put a 1 foot radius on those noses. Break this line first to establish our pedestrian refuge area. And just trim. Will end up being our markings to match. So we just have these as sort of guidelines for now. So once we have those established, we now can look at our transition zone in between our 2 foot offset for our entrance curb and gutter and our shoulder on the approach and start to build in our bike amenities. The GDOT Roundabout Design Guide recommends an 8-to-1 taper to transition from the shoulder to the curb and gutter line through the entry. That 8-to-1 transition allows for a smooth merging of a cyclist that might be on the shoulder into the travel lane to traverse through the intersection as a vehicle. Another option would be to provide a ramp at the end of the paved shoulder that would allow for cyclists to instead go up onto a shared path along the roadside. That is an option for single lane roundabouts. For 2-lane roundabouts, a bike ramp is a typical item to include in the design. But for single lane configurations, definitely consult with the project team and have that be part of the discussion about how we're accommodating cyclists and various trade-offs based upon the site context. For this particular location, we'll demonstrate laying in that taper and laying in that bike ramp. We want to make sure that the bike ramp is kind of within that range that's about 100 feet away from the entrance line, but then about 50 feet back from the pedestrian crossing. So if I just give myself a quick reference line here, and come back 50 feet from the crosswalk location. So really, I want to have that bike ramp somewhere right in this area, which is going to end up being pretty ideal for tying in a taper right into this initial entrance curve. So if I was pulling a tangent off of this entrance curve, I'm going to end up tying in a few feet back from where this would be where this perpendicular line would extend down. And for a 5-foot paved shoulder at an 8-to-1 taper, I'm going to need to come back at least 40 feet. So I'm going to actually set myself an offset line here from the end of this tangent. And I'm going to offset that back 45 feet just to account for the fact that I'm going to be tying in tangential to that arc instead of right to that point. We're just going to use this as a reference line. And what I'll do for setting that 8-to-1 taper is I'm just going to tie in from this point on the shoulder, and then we'll go tangent to this entrance curve along the outside curb line. And I can delete some of these other reference lines and tidy this up. And so now I've got the end of this taper kind of right at that 50 or that 100-foot offset from the ICD. And if I just do a double check to make sure I ended up with right around that 8-to-1 taper. There's my tie-in point almost exactly at that 40-foot distance. So we ended up with a nice smooth taper that ended up tying in directly to this entrance curve so that we end up kind of minimizing the number of inflection points along that curb line and number of unique geometric elements. So that'll set our curb line. And so we'll end up with our curb line coming back at least to this point. Now, if you have an urban section, this curb line could easily extend along the shoulder instead. For this particular location, we're assuming an open section where this is transitioning into a drainage swale along the roadside at this point. But we'll end up with needing to put in that bike lane, bike ramp right here at the end of this transition zone, right at the end of this taper. Before we get too much further, let's go ahead and start laying in some of our sidewalk that we're going to tie into. So if I look at my curb and gutter line here, I'm going to end up with a type 2 curb and gutter along the outside. So we'll end up with a 6-inch offset to get to our back of curb through these areas. And then what I want to do is go through and establish the face of my sidewalk. And so I'm going to do a 6-foot offset to the face of sidewalk. And the reason for the 6-foot offset is it allows us to have a pedestrian ramp in there that doesn't require any sort of depression or adjustment within the multi-use sidewalk facility along the roadside. So all of our ADA ramp can be within this buffer area. And it also allows for some additional room for signing and things like that along the roadside. In some cases, you may not be able to have that wide of a buffer, and we will need to make sure that we're getting at least a 2-foot setback between the back of curb and the sidewalk within the vicinity of the roundabout for ADA purposes to make sure that the edge of the roadway is detectable to a visually impaired pedestrian. But in this case, we'll set that as our face of the sidewalk, and then the back of sidewalk, we're going to set 10 feet back further. You can see that I've got some other sidewalk elements that have already been set up for the rest of the roundabout that I'm going to tie into. And we're just going to trim to match. And so right along these elements, we're going to have a consistent 6 feet. You can see that in these two corners, we're ending up coming in tighter to that back of curb. And that's just because of some right-of-way constraints in those corners that we need to make sure that we're getting at least a 2-foot offset from that back of curb like I just mentioned, but we can deviate and pull that in tighter where necessary. So if I continue to carry this 10 foot, now these will end up getting carried further down and ultimately transitioning into our roadside sidewalk that would be along the outside. The distance here is going to vary depending upon our drainage needs. And so ultimately, as this sidewalk continues along this facility, this distance will really be dictated by what's needed for the roadside swale and the associated roadside topography. So we're just going to push that out there for now. Along this section here, as we're tying in our bike ramp, what we want to try to do is get a 30 to 45-degree angle for that ramp established. As we discussed before, we want to try to get that ramp sort of at the top of the taper here, both to allow more time for that cyclist to be able to get off the roadway and make a little smoother movement, but also because that's where it falls within that sort of 100-foot setback from the entrance and 50-foot back from the crosswalk. So one way to do this, there's many different ways you could tackle identifying the location here, but just create an offset. I'm setting a 1-foot offset line for reference and extend that to where it intersects the curb line. And what I'm going to do is rotate the curb line 30 degrees to establish the center line of my ramp. And we're going to just put it where it's intersecting there. Let's create a copy. Try that again. So we're going to use that as the center line of our ramp. We can delete this other line, and I'm going to offset this 2.5 feet to end up with a 5-foot overall width for this bike ramp. Then we can trim that down to the curb lines and to tie into the path and delete out our center line. So what we end up with is that 5-foot ramp that's near the top of that taper, near the start of the taper. But as a cyclist is sort of in the middle of that lane, gives them the ability to get up and onto that ramp with a relatively gentle movement. But it's not allowing them to kind of maintain full speed and come straight on. They do still have to make a little bit of a movement to navigate up onto that ramp and up onto the multi-use path where there could be other pedestrians present. So we want to try to control that speed somewhat coming up, but still provide a smooth transition. So that gets us our ramp geometry up onto this shared use path. For the other side, we'll do the same thing. We want our 8-to-1 taper and then our ramp back down onto the shoulder. If we begin turning on some of the work that we had previously completed, we can finish detailing out that curb transition, that 8-to-1 taper, and then the bike ramp from the sidewalk multi-use path down onto the 5-foot shoulder. Note that we haven't tied this into another facility. At this point, once you've gotten past these bike ramps, if you are not having a continuous path facility, this could be narrowed back down to the typical 5-foot sidewalk and transitioned back in to the longer network facility on both sides. We finished detailing out a few other elements as well in terms of detectable warning surfaces at the top of the ramp to delineate the edge of the roadway space from the pedestrian space, as well as making sure that we've got our curb ramps or ADA curb ramps at each end of the crosswalk with our detectable warning surfaces at the bottom of the ramp along the delineation of the roadway, and detectable warning surfaces along each side of the splitter island as we discussed previously. If I zoom out a little bit further, we talked a little bit about some of these transitions that we can make with the crosswalks and the sidewalks. In this case, we've got this pinching down to a 2-foot offset from each of the curb lines in these corners because of some right-of-way constraints. Along these other sides, we have a full 6-foot being maintained because of a lack of constraints. We were able to just maintain that for continuity purposes. Then you'll note that there's a couple of interesting elements on this north-south roadway where we actually have an outside truck blister that's been provided. Between the back of the truck blister and the sidewalk, we want to make sure that we're maintaining at least 2 feet of separation along those areas on both sides. So both of these are maintaining at least that 2-foot separation, again, to delineate the ped space from that vehicle space. And then these crosswalks have also been set back a little bit further. So these are 2 car lengths back on these 2 legs instead of 1 car length back. And that was really just to allow for those crosswalks to be set so that the pedestrian crossings weren't cutting through those outside aprons. Um, Along this east-west roadway, both of these were set back 1 car length, the standard location, because those outside aprons were not required in those locations. So the last thing we want to talk about is setting some of these outside aprons and specifically setting the width of the truck apron around the central island. What we want to do is be able to establish this width based upon the actual swept paths of our design vehicles. For a much larger diameter circle, you may need a slightly narrower truck apron. For a very small diameter roundabout, you may need a wider apron. So that truck apron width is not going to be fixed. It's going to vary site to site depending upon the overall composition of the design and particularly the ICD that's been selected. So we've already previously run the various truck paths. And so if we just kind of toggle those on and off here, you can see WB67 through path east-west is accommodated through the entries and exits. And the trailer is just tracking a little bit onto that truck apron there. Same with the north-south. We really didn't need any of those extra outside aprons for the standard W67 design vehicle. And we're not needing the full width of those aprons either for the through movements. Right turns don't use any of the aprons. The left turns is where we start to need a little bit more width. So as we're getting into looking at these left turns around the central island, we have some areas here that are getting a little bit wider that's needing a little bit more width in the through paths. The same in all the directions here. We've got some other vehicles that we're looking at in terms of bus vehicles in each direction to make sure that those buses, as they're going through, would not require the use of the truck apron within the central island. And then we start getting into some oversized vehicles. For this particular site, we had a couple different oversized design vehicles. And this is where we started to get into the need for some of those outside aprons. And you can see that they're not needing that whole width all the way back to the ped crossing and the ADA ramp. It's really just requiring a little bit here in advance, but trying to provide a decent transition into that ADA ramp. And as we get along the central island, the rest of that design vehicle is being accommodated within that standard truck apron width in the southbound direction. We've got a couple different design vehicles here that being looked at. In the northbound direction, north-south, we've got a larger lowboy vehicle that's being considered, and that's mostly utilizing the standard truck apron as well. Then there is a longer transport vehicle that was needed in one direction. So that needed to utilize that outside apron here, as well as some additional overtracking area within the central island in order to be accommodated through the intersection. So these considerations, we start getting into our checked vehicle, is getting above and beyond what was needed for the primary design vehicle, and we're getting some additional blister areas in the central island, as well as those outside aprons to support those checked vehicles. So if we kind of go back through and start turning on a lot of these various vehicles that have been run, this is where we can start to look at sort of that cumulative assessment of where we need to have our truck apron start and end and the widths that are needed. And what we really want to end up doing is providing at least a foot or two of additional space beyond the paths of these vehicles to establish that back of curb line within the central island and that overall truck apron width. This concludes the demonstration. We encourage you to refer back to the GDOT Roundabout Design Guide for additional information related to context-specific considerations for each of the design elements described.